Hello YouTube world, this is Logic Crazy. My name is Jonathan. Today is the second tutorial for Sudoku Solver. Just before that, a couple announcements. One is that I'll be trying to keep the videos shorter. Ideally, I would like to keep it in a 10 to 15 minute basis, but I don't know if that is possible. Given the nature of programming, I like to complete a certain task at least. But feel free to comment on what you would like or what you've seen others do that you enjoyed. Another thing is that in the previous tutorial, and hopefully in most future tutorials, I'll be posting a text document in the description below, and it will contain a link to download all of this text here. At the end of each tutorial, I'll be copying and uploading this text so that you can just paste it in. If you wanted to start, let's say, at tutorial number 13 and skip the previous ones, you wouldn't have to write anything down, although I do recommend not skipping and typing each thing in. And also of great importance is practice on your own. Just try making whatever. Start with simple things, go complicated, and practice is really the best way to learn programming. It's not memorizing, it's not reading books. All those can be helpful, but practice is really, at least what I have in my experience, the best way to learn programming. So for today, we're going to be making a validity checking system. So we're going to create another procedure just like this procedure and the main procedure above it. And before we do that, there are a couple things I would like to change. And one of those, and they basically have to do with these grids, these three grids. The first thing is that this P grid, this third grid, will be used, but let's just turn it into a comment for now. It's really not that necessary this early in the game. But let's select these three things, including the comment. And right now, I should just tell you what I'm trying to do. These variables are created in the main procedure, and therefore they are only accessible by the main. If you call them in the prompt, or try to make a modification in the prompt to user grid, for instance, you'll have an error. It won't know what user grid is, because it only knows about it in its main procedure. So we want to make a global variable. And so what would make sense to do is to put it outside of the main argument, put it outside into the class. So now the class is basically going to be everything that you could scroll to and see. And this will make it global, at least, or a class variable. Everything that's in this class, which is all the procedures we've so far written. And one other thing we want to do is preface this integer with the word static. One more descriptive word, which might get into at another time. And static, may as well put static in the comments here for later use. Alright, so now we have this user grid and this grid as a global variable. So that means main and print, and everything can access it. Then the next thing that we'll start out on is creating a validity procedure. Now the order of these procedures, you'll notice I'm putting this one in between main and print. It doesn't really matter the order. Keep main at the top, and besides that, I order them in usefulness or what makes logical sense, or chronologically. There's different ways to organize it, but organize it in some logical sense so you can find them easier when you're scrolling around. So we will create a public static void. Validity is the name I have chosen, and it will, regular brackets there, then curly brackets at the end. I'll be describing most of these later, but what we want to have this procedure do is return a true or a false. Is this Sudoku valid or not? And so instead of returning void, returning nothing, we're going to return true or false. And true or false in programming is known as Boolean. I'm sure lots of you are familiar with that. And the way you would return is inside if you said return true. And true would be returned after the procedure is run. And then validity, we want to receive certain information just like the print did. Print procedure received a grid so that it could print out that grid. And now we are dealing with global variables, but we'll still be inputting, which is still possible. We will create an int x, an int y, and an int array called grid. Now, we will be deleting this to return true. We don't want it to always return true about the validity. So basically, the reason I have an x, the int grid should make sense. The reason why I have an x and a y is because that's how people think. When we check the validity, we don't go through, on a Sudoku, we don't go through each square saying, oh, are there more than one of these digits in the row, column, or square. What we do is, as we write down a specific, fill in a specific square, we check if that square's row, column, and square, and check if there are any other of those digits. And so that's what this x and y will be doing. It'll really be saving the program time by just checking that one latest spot, that xy spot, which we've just written. So inside of there, we will begin with making an empty string called temp. Normally, I don't like calling things by names that are words like temp or various other things that aren't descriptive. Even the xy, that refers to a graph, and that's why I have x and y. I didn't pick a and b, for instance. Alright, so I have a temp string which is blank. Then we're going to create a for loop, and we've done this in the past. I'll actually just copy the for loop, mainly because I'm lazy. There's a lot of typing in programming, and yeah, it's just quicker to copy and paste sometimes, or you just really can't stand writing it again. Alright, so we're going to temp plus equals. Now remember, plus equals appends, with strings, it appends what you're adding to the end. It just places it at the end. It doesn't do arithmetic addition. It's kind of like writing this and this and this in the same line. But it doesn't use an and symbol, it uses a plus symbol. And then we're going to put in here grid I, y. Alright, semicolon. And I just want to put in description. I just want to show you what this will do. As I loops from 0 through 8, yeah, 0 through 8, so you could think of it as 1 through 9. This grid, the y will stay the same, so it will keep checking across all the squares, intersecting at that xy position, since I will eventually equal x, and it'll basically check in a horizontal line, and it'll append all those digits, which right now are all zeros, but it'll append whatever they are, all in one big long string. And we will also add the grid of xi. And this is the same way, only going the other way. I believe this is horizontal and vertical, although I have to think about that. One thing we do want to change is that this grid IY is a letter, a digit, an integer, I guess, and we want to change it into a square, and to be safe we will do, this is more for future use, but we will do integer dot to, just put a space here, integer dot to string, and put that grid inside, and basically, that's my problem. I was trying to hit control space and get a quick autofill thing. There we go. Whoop. Integer dot to string. Alright, so it takes an integer and turns it into a string. And this is the integer, and it becomes a string. Alright, now we have that third one, that square. And these are all straight rows of 9. But this one is 3 rows of 3. But we can write it in one line if we use the math correctly. So we will again do this integer dot to string, and put a comment here, square, so we know what we're working on, and it would be a grid something something. It'll make 3 rows of 3. Now the question is what? The first thing we'll write in these grids is something that will notify it about the topper. What's the top left corner of the grid we're in? So whether it's 1, 0, 0 or 1, 1, both answers should produce 0, 0. We want to get that top left corner. And so we will write in here, I believe it would be x divided by 3 in brackets, and then times 3. And then in the other one it would be y divided by 3 in bracket times 3. Oh, I didn't start the bracket. There we go. And what this does is, this is how Java divides numbers. These are both integers, that would be whole numbers, no decimal places, and so therefore when they divide, it doesn't write decimal place. And when Java divides integers, it doesn't round, it just provides the whole number at the beginning. So 1/3 and 2/3 both produce 0, and 3/3 produces 1. It doesn't round up 2/3 to 1, it just leaves it as 0, because it would be 0.66, and so it just says 0. So in our example of 1, 1, we want to produce 0, and so you'll notice that both of these produce 0, and times them by 3 does again. Now let's say our number was 8, 8. That would be the last digit. Remember, it's not 9, 9, because we start 0. 8, 8. Now 8, 8, 8 divided by 3 produces 2, and there's some remainder, but it produces 2, and it times it by 3, which is 6. And the same goes here. So it remembers that the upper left-hand corner is 6, 6. So that's basically the math to get that top left corner of this current square. And then to move across in 3 rows of 3 from there, we have to add something. Add I divided by 3 to the 1, and add I modulus, or percent sign is what it is, 3. This percent sign is called modulus in programming. And so we already know what the divided by 3 does with integers. It provides 2 integers divided by itself, produces an integer. It doesn't change what type the answer is. And so this, for 0, 1, and 2, this will remain 0. And then for 3, 4, and 5, this will produce 1. And so every 3, it jumps to a new line, you could imagine. And with this one, modulus produces that remainder. So 1/3 will produce a 1. 2/3 will produce a 2. 3/3 and so on will produce a 0, I guess. And so basically what it does is it takes I, divides it by 3, and gets the difference. So in the traditional, this I divided by 3, let's say I was 2, it will produce 0. And now it says, what's the difference between 0 and 2? Oh, the difference is 2, therefore the remainder was 2, and that's what modulo does. So this will jump each time, and it'll go from 0, 1, 2, 0, 1, 2, 0, 1, 2. And that produces your horizontal shifting over and over for each line. Alright, so hopefully that made some sense for doing a square. The modulo might be new to some of you, depending on the programming language you've used. In GameMaker, I will note that this divided by, or this, modulo is MOD, is what you would type in GameMaker, and this is div, because it ignores the decimal places. So that's just the equivalent on that side. Alright, so now we'll create an integer now that we've strung everything together. Oh, and please note, this is important to note, that whatever was at xy should have been recorded 3 times, because it intersected on the row column square. Alright, so we'll create a new int. We'll actually create 2. One being count, if I can spell right, and we'll set that to 0, and just put a comma because we're creating more integers, and we'll create an IDX equals 0. And this is how you create 2 integers in one line. Since they're all the same type, you just put commas and keep writing. And these spaces, Java isn't too worried about spaces. You can get rid of them or not. It's more of a preference. Alright, now we're going to see if we can count how many times the spot xy has, and return count equals 3. Alright, hopefully this will work. So what we'll do is we'll put in a while, couple start brackets, and IDX equals temp dot index temp dot index of temp dot index of integer dot toString, and in the toString we'll write in grid x, square brackets, x, y, grid x, y, and then an end bracket, comma, and here it would be IDX as it has guessed. Then I believe 2 more brackets and an exclamation mark equals -1. So it's checking if this location is the location of the is the same as the xy value, and if it's not, it would return -1. This not equals is the opposite of equals equals. With Booleans, trying to get a true false answer, you do a double equals, not a single equals. A single equals will say, temp equals 5, and temp would become 5. That's what a single equals does, is it sets a certain variable to a value. But in this case, we're wanting to compare. We're just saying, are they the same? And so we're getting a true false sort of Boolean answer. And so you would do a double equals, and if you want not equals, you do exclamation mark equals. Exclamation mark is kind of like the not. Okay, and now on the next line, this is what it'll do while it's not. It will count the IDX plus plus And then instead of writing a new line, although you could, we'll just say the next thing, count plus plus. Alright, and then we return if the count is 3. Hopefully, in a valid solution, the count would be 3. And that is how the validity works. So now Boolean will return if it's true. So, for instance, let's just do a quick test here. In our main, before we print the grid, we will say, just so we can see the result, system.out.println, and then validity. Now, do note that X and Y need to be mentioned. We will leave them at 0, 0, which means it will check the validity location 0, 0. And with arrays, it starts at the uppermost left-hand corner as you read. You go across horizontally, next line, across horizontally, next line. And you would end at this line after coming horizontally from there. All right. So we want to return the validity, and we should receive a false. I am hoping. If all was correct. Yes, we received a false because it takes this 0 and says, ha, it's all over the square column and row. But if we put in a 1 there and run it, now we still get a false. That is because we are checking the grid and not the user grid. And the grid we have only established to be, we've only established it to be just like the other, just like the user grid. So what we would need to do is before this put in a for loop, I guess. See if I can just copy it in from the bottom. Yeah, from this print. If I copy and paste this for loop to make the grid look the same as the user grid. So for each one, get rid of this print line. For each one, grid ij equals, and we'll do user grid I j. After it runs that, so we'll get a false, because this is 0. Now I set this as a 1, and it still produces the same thing. So I will have to think about what exactly the bugs are. Could try changing this to user grid, and I will let you know on the next tutorial. Alright, until then, enjoy Java.